Okay, good day. My name is Carlos Corona. I'm going to present the final exam for the design and analysis of experiment course. So I have data sheet 1 of data. I was practicing before starting. So this is the data that I will use for the exam. And okay, let's go for the Minita to begin. So first of all, we need to create our factorial design. So I will go directly to the DAE and create factorial design. And we need to see on the table which factors do we have. We have two. And okay, we're going to select full factorial design. We have 5 center points per block, only one replicate and only one block. And I will keep randomized runs because of the table. Okay, let's see. I will order differently this column. Yeah. So we have our factorial design created. So I will copy the data from the Excel table. Just let me put these names. We see that everything is correct, like our data, and we're going to analyze factorial design. So here we're going to select both responses. Okay, for the first time, we are going to select normal and have normal plots and 4-in-1. Other like that, I think there is no more to select. Okay, yeah, okay. So let's see. Okay, so we have an R square undefined 98. So this is also an error. We do not have many information here. Okay, we can see that A and B are significant and the normal plot, but AB it is not. And also in half normal, we can see A significant, B significant, but AB not. So we see on the Pareto chart, and effectively, we can see AB, it is not significant. So we can try removing that factor, that term. So also no normality assumption fulfilled and no constant variance. So there are initials on residuals. So we are going to analyze factorial design again, and on terms we're going to remove A, B. So okay, okay, let's see. Okay, now we have a value on R squared 97.83. We see our values. They look well. Normal plot and half normal plot, they are significant. Also on the Pareto chart, both are significant, and we can see now that there is normality on the residuals and constant variance, so we can see that our assumptions are fulfilled. So, well, what can we do now? Well, we also can do the factorial plots to see our values. We can see corner and center points well, and we can see we can do our power analysis. Number of factor 2, corner points 4, replicates 1, effect. We need to see on the effect. Oh, also we need to see on both graphs because we have 2 responses. So also in the other response we have 99.71% on R square. It is a very high R square. We can see that here A and B are not significant. They are not significant, and we can see an linear behavior, but it seems kind of weird. And well, we can we can do the power analysis for both responses. So let's see the least factor effect, A, and also we need the standard deviation. So we need to remember these numbers. Okay, and also 0, 0, 0, 25. Let's do power. Okay, there is one term omit. Okay, let's do like this. And we can see our power very, very low. Also, for the other one, we need to remember in this case, it is B on the effect, the less effect, and also 2.360. So we change this and this. Here we can see a high power or a higher power curve for this level factorial design. And now we need to update our data in the table. So we are going to do another factorial design for the table 2 on the experiment or the data that we have. Now we're going to select 9 center points per block. The rest remains like that. Factors. Okay. Randomized runs. Okay. Now I will order this smallest to largest. And now we need to manually change one of these factors or values. Let me see. Okay, this is positive. Okay, and now I will copy the data from the Excel table. I will put it Now, again, analyze factorial design. We are going to select both responses. Terms, well, because it is the first time we're only to select normal and half normal, and from one again. And let's do. Okay. Now, let's begin with the first response. We have, okay, we see that we have a value, but they are not very good values. R square is very low. And so we are going to see what is going on. So we can see that it does not recognize this as significance, but not significance. We can see that they are not significant on the Pareto. We can see almost linear behavior, something like that, but this is almost unusual in the response. Let's see the other one. Okay, here we have a very good R square, and okay, everything seems very normal. Again, A and B is significant, AB not significant, the interaction. And okay, yeah, also at the half normal plot, we can see AB not significant, but A and B significant. So what we can do, let's see residuals. Residuals, they have very linear behavior and constant variance. So we see these residuals very good. The response are very good, but we need to remove this AB value. Let's see what happens. Analyze factorial design. Okay. Nothing else. If this doesn't work, we can do a Cox-Blood transformation, but let's do one thing at a time. Okay, this remains very well. It doesn't change too much. So we are going to assume we are good here. By the other side, we can see we do not change too much. We only remove the values, but they are not good at this point. So we are going to try the Cox-Blood transformation. Let's see. Optimal lambda, Box-Cox transformation. So we can see we elevate the R square. It is not good at this point, but it is better. It is well, not so much better, but it developed something better answer for us. Okay, so we can do the factorial plot for these two on response 2. Let's do. I will do for response 1 also. Yeah, well, we will not have a very good plot, but let's keep with this. So we're going to do the power analysis for this response that we have. Good. Okay, let's see. Which was, yes, this. Okay, we will use, well, no, before box cuts transformation, we're going to use this. Okay, the effect 5.336 and standard deviation 3.230. Okay, let's do our power analysis. So, okay, number factor 2, number of corner points 4, replicates effect 336, standard deviation 3.23, and number of center points per block 9. We are going to, okay, sorry. Yes. Well, we can see a power of 0.31. It is not too much, too high power. I think I forgot something. Let me see. Okay, let's go to the two-factor sum, two corner points. Yeah, this for this. No, I think it is not correct like this. It was correct. Well, this is what I obtained from power analysis. You can see it is not too much high power, but this is how I obtained this result.